Hi, welcome to Unit 5, Similar Triangles. Today's lesson will be ratios and proportion. The objective is, how do we write ratios and solve problems with proportion? So before we do any work dealing with proportions and ratio, we need to know the definition. So ratio shows the relative sizes of two or more values. And the unit ratio has a denominator of 1. So unit ratio is your, I would say, like your starting point. Like for every $1, you can get 3 oranges. And then you set up a proportion to show, okay, how many oranges would I get with $2? So in that case, that would be a comparison of comparison of more than 2 quantities is called a ratio. Because again, you're comparing one to the other. So for $1, you're getting 3 oranges. And if you got $2, then you get 6 oranges. And this leads us to proportion. And proportion is a statement where two ratios are equal. And you'll have a formula or an equation where it's A over B equals C over D. And you could also write it as A to B as C is to D. When it comes to proportions, there's different terminologies to know which things you're working with. So the means are the middle terms, so B and C. Notice where they're positioned. And the extremes is A and D, the first and the last terms. So when it comes to the means and extremes, you're going to do an equal cross product. Oops, I put that down here, where you do the product of the extremes equals the product of the means. So that means A times D equals B times C. And this is how it works when you're dealing with proportion. So again, proportion is two ratios that are set equal to each other. So going back to the example when it says when I said that if you were to buy 3 oranges for $1, how much would you buy? How much would you get with $2? And we know that there's a constant factor of 3, so then that means you would get 2 to 6. And then if you were to find out for $3, it'd be 3 to 9, and so forth. And all those ratios set equal to each other are in proportion because of a certain, a constant factor. All right, so we're going to do examples based on the unit ratio. So the first one says 1 ounce of cheddar cheese contains 9 grams of fat. 6 of the grams of fat are saturated fats. Find the ratio of the saturated fats to the total fat in an ounce of cheese. All right, let's look at the information that they gave us. They said that there's 9 grams of fat in the cheddar cheese, and then 6 of them are saturated fat. So we need to find the ratio of saturated fat to total fat. And usually to help yourself, you can always set up what they're asking you to look for, so that way you know where to place your numbers. And usually when they ask you to find a ratio, they put it in a certain order. So if they have whatever first, like they have saturated fats to total fat, then you know that saturated fat will be in the top, total at the bottom. So we know that saturated fat, they told us that there would be 6, and then the total is 9. We can reduce this. Anytime you see a fraction that you can reduce it. So we know that the constant factor for this is going to be 3. So then we have 2 to 3. So that means for every 2 grams of saturated fats in that cheese, there is 3 grams of fat for the cheddar cheese. So this is our unit ratio. So basically that ratio is the fraction that we start off with in order to find our other ratios that is proportional to it. So next one, in a schedule of 6 classes, Martha has 2 elective classes. What is the ratio of elective to non-elective classes in Martha's schedule? So we know that in order the ratio, we're looking for elective to non-elective. So she has 6 classes, 2 of them are electives. So I'm going to put 2 on the top here. We need to know what the non-elective classes are. So if there's 6 classes, 2 of them are elective. So then we just do 6 minus 2 and we get 4 for the non-elective. Then we put that 4 here, and we know we can reduce this fraction. So I'm going to reduce it to 1 over 2 because 2 is a constant factor. And we have our unit ratio. So 1 over 2 is our unit ratio. So that means for every elective class she has, 2 of them are non-electives. And then 2 over 4, and then 3 over 6. That is the ratios that are proportional to the unit ratio. Third one, a tight end scored 6 touchdowns in 14 games. Find the ratio of touchdown per game. So that means touchdown per games, T over G. So we know that the tight end did 6 touchdowns in 14 games. So we need to find the ratio. This is the ratio, but we can reduce it. Constant factor for both of them is 2. So it will be 3 over 7. That is our unit ratio. So think of the unit ratio as the most simplified reduced fraction. So that means for every 3 touchdown that is made by the tight end, this happens within the 7 games. And a 6 over 14 is what's proportional to the 3 over 7. All right. We're dealing with ratios and triangles. There's another way that we need to set it up in order to find the constant factor in order to get our total. So think of it as if we're starting with an original triangle, and let's say we want to double it, triple it. We would use a certain factor, scale factor, to triple it, to double it, in order to get another triangle that is proportional to the original one. All right, so the first thing, let's read it. In the triangle, the ratios of a measure of 3 sides are 4 to 6 to 9, and its perimeter is 190 inches. Find the length of each side. So we have to do, this is a 2-step. We have to find that missing variable so that we can plug it back into the ratio in order to find what the sides are. So what I'm going to do is I'm going to draw the triangle. I'm going to put 4 to 6 to 9. Again, we're dealing with sides, and they gave us the perimeter of 190. And remember, perimeter means the outer shell of the triangle. It does not, when you have to add up sides, it does not equal to 180. 180 belongs to the angles. I know most of you do that mistake. Just realize angles, 180, the sides, if they give you a perimeter, you're using that. Or if they don't, you add it up. But in this case, we're looking for, since this is a ratio, that doesn't mean we do 4 plus 6 plus 9 and find whatever number, because basically we're just using the perimeter. But they gave us a perimeter. That means we need to find that factor, that constant factor that we need to apply to find the sides. So in order to do that, we have 4x plus 6x plus 9x equals 190. That x that we need to find is going to be our constant factor in order to find the sides. So that will give us 19x equals 190. We divide it by 19, and then we get 10. But that's not where we stop, because we need to find the sides. So we're going to take each of the sides, that's our ratio, and then plug in 10 and find the measurement for each side. So then that means we'll get 40 inches, 60 inches, and then 90 inches. And if you add them all up, you'll get 190 as your total perimeter. So this is what they're asking us for. All right, let's do the next one. It says in the triangle, the ratio of the measures of the angles is 4 to 5 to 9. Find the measure of each angle. So that's the last thing that we need to do. And I'm going to draw the triangle, mark up the angles because they said angles. I know that this is going to give me the angles are going to give me 180 degrees for a triangle. So 4 to 5 to 9, we set up our equation. 4x plus 5x plus 9x equals 180. And then we solve. So this will give us 18x. And then our x will equal 10. But we are not done. We need to find the angles. So that means we plug in 10 to wherever there is an x. Let me go back and do that again. And then we simplify and find our angle measurement. So we got 40 degrees, 50 degrees, and 90 degrees. And if you add them all up, give you 180. Okay, so again, we use the constant factor to the ratio in order to find our angles or sides. So again, anytime we're dealing with a ratio and triangles and you see this setup, you know that you're going to do 4x plus 6x plus 9x equals whatever they give you. If it's a perimeter or if it's an angle, it's dealing with the triangle angles, 180. Okay, and then there's other questions where you have to find the variable based on how they set up the proportion. So for this one, I'm going to, let me highlight it. Anytime you see this setup, you know you're going to cross multiply. You've done cross multiplying before, so this shouldn't be anything new for you. Basically, you're just solving to the missing variable. So you have 6y, and in that one, 9 times 18.6 will give you 167. .4, and then you divide by 6, and then that should give you 27.9. Okay, same thing with this one. When you have an expression, put it in the parentheses because you know you're going to be distributing. So that gives you 24x minus 30, and then that will give us negative 78 and 24x, and you add in 30 to both sides. And then you'll get negative 48. Divide that by 24, and you should get negative 2 as your x. And if you were to plug that in, you should see that the proportions, the ratios would be in proportion or equal to each other. So this one would be negative 8, give you negative 13, negative 13 over 3. If you doubled it, then you give you negative 26 to 6. So if you reduce this, it would be negative 13 over 3. So that means x equals negative 2 is correct. That's a way to self-check. All right, next problem, you're going to be dealing with proportions in word problems. So again, as for any word problems, you read it first. Then the second time around, you see what they're asking you for, what they gave you and what you need to solve for. So it says, throughout Lewis Carroll's book, Alice's Adventures in Wonderland, Alice's size changes. Her normal height is about 50 inches tall. She comes across a door about 15 inches high that leads to a garden. Alice's height changes to 10 inches so she can visit the garden. So there's two things we need to do. We need to find the ratio of the height to the door to Alice's height in Wonderland, and then how tall would the door have been in Alice's normal world. So the first thing we need to do is figure out what information they gave us. So they said that her normal height is 50 inches tall, and the door and her height changes to 10 inches. So let me put that in another. So it changes to 10 inches. Now let's go back to the door. So we don't know, oh yeah, she comes across the door and it's 15 inches high. That leads to the garden. So what I'm going to do is I'm going to put that in another color. So the door is about 15 inches high, and that leads to the garden. All right, so that means that door was already 15 inches high, and she had to shrink to 10 inches in order to fit through the door to get to the garden. So now I have an idea of how I'm going to set up my ratio. So I'm going to put her height is 50, and she shrank to 10 to get to fit through the door. So that means, and I'm going to use another color for this. That means that for the garden door, oops, let me make sure she shrunk. Yeah. So that means for her to be 10, and for her to fit through the 15-inch door, she had to change her size to 10. So that means I'm going to put it down here because this represents the garden size. So we don't know what the door size is. So I'm going to put that as X. And then to make this clear, actually I'll start with the purple, purple one. This represents, let me see, trying to make sure I have this right. So she shrank to that, and the door is that. So for the bottom part, which I should have used another color with that, but whatever, this represents the garden height requirement. And then the top represents actual size. Okay, so I have the actual size over the garden height requirement sizes. She needed to be 10 inches in order to fit through the 15-inch door. So now, since we set up the proportion, now we can find out what would the door be, the height of the door be in her world. So I'm going to go back to the ratio that I've set up, and I'm going to solve. So that means I'm going to cross multiply, and I'm going to use the highlighter to show you that I'm cross multiplying. And then go back to doing that. So then that means I got 10x equals 50 times 15. And then that will give me 750 divided by 10. And x will equal 75, and that will be inches for the door. Right. So again, this is applying what you've learned about proportions and ratio in order to find something in reality or whatever the case may be. So again, when it comes to doing that, you have to know how to set up the ratio, and then you could set up the other ratio equal to it in order to solve what you need to solve. But that only happens if you read what they give you the first time around, read it first, and then the second time around, pick out the information that they gave you in order to know how to set it up and then solve. All right, so I think that is the end of that. So just as a recap, we learned about ratio and proportion. So we know ratio shows the relative sizes of two or more values, and then the unit ratio has a denominator of 1. So it's for example, if for every $1 you're getting 3 oranges, and then you would set up a proportion, which is a statement where two ratios are equal. So you basically, in order to find the missing information that you need, you're multiplying the product of the extremes with the product of the means in order to get your missing variable. So we've done examples, and then with ratios and triangles, it doesn't even have to be with triangles, it could be with any shape. So if you had 4 angles and they give you a ratio, like let's say 1 to 3, 1 to 2 to 3 to 4, and you got a perimeter of 500, you would have to do 1x plus 2x plus 3x plus 4x equals 500 in order to find that scale factor, in order to find the actual sizes. Because with ratio is basically like I would say the bare bones of whatever you're working with, and then you have to find a constant to find the actual values for whatever you're trying to figure out. And proportions, cross multiply, find your variable, and that's it. Okay, so if you still have any concerns, any issues, confused about anything, you know that you can always email me and give you examples so that way I can help you out. All right, so this ends our lesson, and have a good day.